So we have here another line, 2x plus 5y is equal to negative 10. And a point not on the same line, we have 2, 5. It is represented by this Cartesian plane. And by the way, this is already provided by one of the videos pertaining on the identification of the foot, which actually presented in this here. Okay, and the same process of determining the foot is already provided at the bottom, which yielded to this value or the coordinates of our foot. We know that it's in the third quadrant because the foot is presumably based on the graph is on the third quadrant. But we will no longer talk about the process of determining the foot. We're going to determine here the distance of the said foot to the point X, not on the line. If we're talking about this in our high school years, is actually the shortest distance from that point to the line. At the same time, if you are going to use the distance formula, since you already identified the foot of the given perpendicular, you can always get the same value as the value we're going to present later. Now, the point here is we will no longer use that high school process, but we're going to use the same process in solving the foot, because a portion of this is already of the formula in determining the distance of x to the foot of the perpendicular, which is x. So we have here this region of the formula. This is actually the distance of x and f. And yes, you got it right. We will no longer talk about the long process because we already presented that here, because this region is this portion. Sorry for that. That means another color. This portion onwards. So we'll go back to the formula. We have here the inner product of x minus p and your unit normal vector. Also, we will no longer discuss how we solve the unit normal vector. Please try to review the video pertaining on the foot of the perpendicular of this given, because it's already there. And by the way, if we're talking about distance, we're going to take the absolute value, because this inner product may also take negative value, especially that our some of our points as components of the vectors may have negative signs, so this will be negative. Hence, for distance, let's take the positive region. And going back here to the formula, again, it's already here, which also provide here. So we can have this value as the scalar, and this scalar value is actually the distance. So you have 39 over square root of 29. So again, the value here is actually equal to 39 over square root of 29. If you are going to rationalize that, you may, and you will get a better answer, which is 39 square root of 29 all over 29. This is the distance of x, which is 2, 5, and f, the foot of perpendicular, which has this following coordinates. I urge you to check this using distance formula and also get the equivalent value for this in decimal notations and check whether, or verify whether your answer is correct or not. But nevertheless, this is the distance of point x to the foot of perpendicular on this given item. Thank you very much for watching.